Let's see, 1, 2, 3. Are you able to hear me now? Yes? Am I audible? Am I audible now? Anyone say hi?
Yes, ma'am.
Yes, ma'am, you are audible.
Yes, ma'am.
Hello, ma'am. It is the subject is software quality and security, right? Yes, ma'am. It is the unit for software quality and security, right?
You are not audible. You are not audible.
Am I audible now? Hello?
Not properly. Just be a little louder.
Yeah, I am saying that we are going to study about software quality and security, right? Unit 4.
Yeah. So, yes, I'm going to start. Everything seems to be okay now. Okay, I'm now. Just वीडियो लगाने को है हो जाएगा ना. So yes, now let's start the session. Today we are going to start block 1, unit 4, which revolves around different aspects of the quality. So that is software quality assurance. The software quality assurance is a very bigger topic. But still, I will try my level best to cover these dimensions which are the part of your course curriculum also. So, software quality assurance is what basically it is a series of activities which is undertaken through the software engineering process. Because I think that rather I must say that yes, quality is a cumulative sum of various factors which are involved in bringing about the quality. Somebody is trying to answer. So that cumulative sum that I was talking about, that software is not achieved by chance. It is not an accidental, scenario which is created. It is a conscious approach which is applied in the development of the quality software. So today in this session we will talk about only those aspects of the software which will be able to, by doing that aspect, we will be able to apply the quality into the proposed software, right? So this is the only agenda. And from the software engineering process, we have to we have to apply lots of engineering practices that help to achieve the quality of the software. It comprises the entire gamut of software engineering life cycle also. So the objective of the software quality assurance process is to produce high quality software. So that means, and quality always revolve around the customer requirement. So through process of applying various procedures and standards, we will be able to achieve that Q dimension, that is quality dimension of the software. So quality software is reasonably bug free, means if I am going to develop any software and if it is full of bugs, if it is not delivered on time, if it is not within the budget of the customer, if it is not meeting the requirement, so you can't say that it is a quality software. Apart from this, we always looking for a software which is maintainable easily also, right? So these are the aspects that we have to take care while maintaining the quality of the software. Software quality is any software is said to be a good quality software that satisfies both the explicit and implicit requirement. And when we talk about explicit requirement, it means the requirement which we as a developer jot down after discussion with that of the client, and implicit means what the customer expects. When we think at this level, although it is not mentioned in your book, but still there is a latent requirements also which talks about how to how to create a delighted customer experience. So that requirement all comes under the software quality. So that is why software quality is always said to be a complex mix of the characteristics and varies from application to application and customers who requested for it. So while assuming the quality aspect of the software, we have to take care of lots of aspects of the software. Out of this, the first one is auditability. Auditability of the software means what the customer has asked for it and how the proposed software is serving or it is qualifying, or rather I must say conforming to the criteria of standards basically. If my software which I have prepared, it is conforming against the standard of the company, standard of the requirement of the client, so it means yes, compliance of standards means auditability is there. Compatibility. So the ability of the two or more system or components to perform their required function while sharing the same hardware or software environment. In this regard, the compatibility can be assumed in terms of different operating system, in terms of different browser, in terms of different data models and hosting, many more aspect of the software which actually generates the compatibility that will be counted. Completeness. So the degree to which all the software's required function and design constraints are present and fully developed in the requirement specification that conforms to the design document in context of the code and all. So when when all these completeness aspect basically reflects the functionality part of the software which revolves around the requirement of the software. So once these requirement is fulfilled with respect to the design and all, so that qualifies against the criteria of completeness. Consistency. Modification is an integral part of any software lifecycle. So the degree of uniformity and standardization and freedom from the contradiction, even after applying so much changes into the document. With respect to the document or the part of the software, they all map to the consistency criteria. Correctness. Although correctness always revolves around the customer requirement, so the degree to which a system or the component is free from the fault in its specification, whatever has been mentioned into the SRS, Again, it is mapping with respect to the specification, design document, and whatever is the functionality of the software in terms of implementation that relates to the correctness of the software. So the degree to which the software documentation meets the specified requirement is called correctness of the software. Modularity. It is always a good practice in the software engineering, and rather it is said to be a approved and recommended practice into the software engineering that the degree to which a system or a computer program is composed of discrete components such that the changes to one component has minimal impact on other components. So that quality in which we create different modules, and these modules are independent of one another, and it is a responsibility of the person who is dividing the entire task or the structure of the entire web application or whatever software we are considering in such a way so that if we are working on a one module, then it should not affect the functionality of another module. So that quality of partitioning the entire work into the different modules so that our software become more manageable also, and we are able to partition the problem in a much controlled and better way. Next one is for predictability. Although the first aspect that we have covered in the first software engineering classes, that in which we talked about a little bit about the business analysis. Every software before it is being developed, it is the business aspect of the software is analyzed in terms of business and all. So that reflects the predictability. So any software which reflects the future prospect in terms of its functionality, in terms of its performance of the software, and determinable for a specified set of input, that reflects the predictability. So before going ahead in the journey of development of any sort of software, we should take care of those aspects which can impact in the near future. So that way of thinking again contributes to the predictability of the software. Robustness. Although most of the software which are releasing nowadays, they all are robust software because they are able to digest small bit of even if the software is not doing well or sometimes not performing well or some exceptions are raised and all, still the software is able to generate the output and all. So that reflects the quality of the software. Even if some invalid input we have given, still the our software is able to produce the output in such a environmental or stressful environmental condition. So that quality of the software is called as a robustness. Structuredness. Again, structuredness is the core feature of any programming language or any practice of the software engineering also. So structuredness means the degree to which the software design documentation and code, they possess a definite pattern in their independent parts. That it means there should be mapping between what was there into the SDD document and what the exactly has been transformed in the form of the code and all. So that attribute of the software is called as the structuredness. Is testability, that is ability to test. The proposed software that I have just prepared or going to prepare, the degree to which a system or a component facilitates the establishment of the test criteria so that I can qualify certain criteria in terms of testing. Either the load is the software is able to take the load or it is able to bear the given stress of the users or let's say memory and all. So that testability parameters can be ensured before the software is actually delivered to the customer. So once the testability is being ensured, then the performance of the test will determine whether those criteria have been met or not. That can be ensured. Traceability. Here the traceability, it again revolves around what the user requirement was mentioned into the SRS. So the degree to which a relationship can be established between two or more products of the development process, and the degree to which each element in the software development product establishes its reason for existing. It means if something is there, then again the things can be mapped, and if something is missing, then again the things can be mapped. So that quality that the things are traceable with respect to the given requirement of the customer and all, that is called as a traceability feature of the software. Understandability. This feature basically reflects how effectively we can make use of those software, and how the different stakeholder can understand the entire view of the software. So that quality of the software is called as a understandability. It means we will consider each and every kind of user, either it is an internal user or stakeholders or our final operating the team or the user and the operating team and all. If they all are able to understand your software, and they are because that understanding is there, it means the degree of usage of that software will enhance basically. So the degree to which the meaning of the SRS and software design document and the code are clear and understandable to the reader, that quality of the software is called as the understandability. Again, verifiability is always measured in context of the degree to which the SRS software design document and code have been written to facilitate the verification and different validation criteria or behavioral aspects of the software that can be ensured. Again, if those software is reflecting all those parameters, then that is called as a verifiability. Even if knowing all those aspects of the quality, still, when the software get failed. So what could all be the possible causes of the error in the software? Now we are going to discuss all those aspects. Sometimes what the customer has told me, I have just misinterpreted that customer in my own way. So that misinterpretation of the customer's viewpoint leads to the error into the software. Again, incorrect communication can lead to, or insufficient rather I must call it, is called as a, it leads to the generation of the error in the software. Incompleteness, incomplete erroneous system specification again leads to whatever you have shared with me, if it is not in completed format or in a complete way. So again, because the complete information not provided at the part of designing, not even in the, because if the things were not there into the designing part, how can it be transformed into the code part and all? So that again leads to the incomplete system specification, leads to the incomplete functionality, and sometimes even the things whatever has been told to me that I have mentioned it in a error form, or we can I'm supposed to write let's say an 8.9, but I have written 9.8. So that kind of error or bug-free statement, the bug-full statement can lead to the erroneous system specification. So there could also be other causes of the error, that is error is there into the logic that I have applied into the implementation of that particular thing. So that could lead to the again error in my software. Not classroom, classroom. एक सेकंड होल्ड कर, मैं जरा Yeah. So, yes, I was talking about those aspects of the software that could generate the error into the software. So that is incomplete testing, because although as per some survey it was evaluated that sometimes just to ensure the quality, extensive testing must be done. But if that not extensive, rather the optimum level of testing must be done. So if that optimum level or approx level of testing is not done, again that could lead to, because incomplete testing is being done, so that could again lead to the error into my software. Accurate documentation or even sometimes no documentation, that can lead to the error into the software. So now we all can imagine the importance of documentation also, that how important it is to include not only to include, rather to get prepared the documentation of each and every activity that we are going to create, that we are going to perform into the software. So it's into the practical classes. I have emphasized also on this part that every time, whatever we are doing, every time we have to make a documentation for the same thing, so that if some errors are cropping up into the later phases of the software development, so that can be flagged or traced basically. Again, another source of the error that could lead to the that could reduce to the quality of the software also is deviation from the specification. I have prepared such a software, or I have developed such a software which is deviating somehow at the part of specification. It is not written anywhere into the software, and sometimes I have lagged certain points also. So if some sort of deviation, this sort of deviation is there, then definitely that again that leads to the error into the software. Error into the data modeling, the way I have prepared the ER diagram or entity relationship diagram or any other data modeling approach that I have used. Again, if it is not projected well, so that can lead to the error into the software. So because our entire software engineering or SDLC process, every phase arises from the outcome of the previous phase. So if there is some sort of error into the previous phase, so again that will get multiplied. So the ratio error gets multiplied in the subsequent phases and all. Characteristics of the software quality. How to gauge the quality of the software. So how many times I have applied the changes? Let me. Some people are trying to answer. Some characteristics of the software quality is that how to gauge the software quality is that how many times I have applied the changes into the design document, how many errors are there into the code, how many bugs are there during the different stages of the testing, what is the value of the reliability matrix and all. All these parameters reflect the quality parameters of the software, proposed software. So again, there is a value which is called as the MTTF, that is mean time to failure, that may be defined as the probability of failure during a particular interval of time is before the actual occurrence of the failure, how the system fails. So how much time it takes. So this parameter also will be discussed in the reliability part, which we are going to discuss in the next unit and all. Another important aspect is maintainability metrics. So maintainability metrics, because software development is a one-time effort, but software maintenance is an ongoing process. So in terms of by knowing the complexity of the software, we will be able to get an idea that after knowing the complexity metric, we will be able to get an idea that how much effort will be required in the maintainability of that particular software. So depending upon the kind of activities or the number of activities which are indulged into the work of the software, that is called as a maintainability, and that can be find out with the help of that which is called as a cyclometric complexity, and the formula is given in front of you. That is this formula. We can use these A, B, C, D. They reflect the number of activities. So after knowing this, graph of the vertices and edges, this node is represented as a vertices, and this line is called as the edges. So the count, by knowing the number of activities which are involved into the software development work, so that vertices and that mapping can be created, so that a holistic view of the things can be find out. And by putting this value, we can calculate the psychometric complexity of the program in terms of number of edges, by knowing the number of edges and number of nodes. So even if we are having frequent discussion with the client and what all is going on.
Ma'am, can you please explain the formula y n plus 2?
Please repeat your question.
Yes, ma'am.
Please repeat your question. I'm not getting your idea.
Ma'am, my question is why C minus n plus 2 is here? N plus 2, what the mean of this?
This one.
Yes,
I'm
ma'am.
taking one example. I'm taking one example to make it clear. Let's say I'm starting. I just want to. I have just launched a software now. Software is in the working condition. Now because we are here talking about the maintainability metric. So means maintainability matrix will give you an idea the amount of effort that will be involved in the maintenance of that software. So if I want to maintain a particular software, so maybe if some errors will be raised by the customer, I need to discuss with that. Again, I need to channelize this discussion, or I have to carry forward this point to the concerned person. Then that concerned person will fix the bug so that the errors can be fixed out. Then I will check it out at my own level, either the said errors has been fixed or not, or the still if the customer is facing any sort of trouble at all. So all these activities, whatever I have just spoke in this example, they all will be reflected in terms of A, B, C, and D, the kind of activities, and which activities is to be related with another activities. These edges are giving you an idea that okay, before going at the fixing part, first the things must be communicated at the right channel at the right point, so that the approval can be raised and all. So these are the ABCD are the kind of activities, and how these two 4 5 activities are related with one another. They are represented by means of edges. So if the graph will be too complex, let's say I'm assuming one more example, C, D, E, and considering E. So and again I'm taking one more example, let's say F. So the number of the keeping in view of the number of nodes. So if the number of nodes in this scenario will keep on increasing, so you will be able to get an idea that okay, lots of effort is involved. If let's say 15 or let's say 26, all the alphabet the A to Z I have included into this graph. So by having this previous control flow graph and this A to Z graph, by comparing these two scenarios, the person will be able to get an idea that okay, because if there are lot many things which are need to be settled down, so the complexity in this part in this scenario is more. It means more effort is required. It means more manpower is involved. It means more costing is to be involved, right? So this is how the things are handled in this. Answered your query? Yes.
Ma'am, I'm still confused. In the term of software, what is the ages there?
What will be the
Ages.
edges reflects the kind of interaction.
Okay. Can we say it like features?
We can say. Because
Okay.
certain things are dependent on one another. Na? So once the first thing will not be clear, then how the things can move on to the next part, right? So
Okay.
like we can say the database manager work on to the ERD, the ERD which is finalized, right? So until unless the ER diagram will not be prepared, how the database administrator will carry on the work. So in this way, again you can call it as a feature, because the quality of the ERD reflects the feature of the things or the software which are in question, right?
Okay, ma'am. Okay, thank you.
Process of the software quality. Again, here we get to know till now that what all are the aspects of the software that we need to take care so that the quality can be achieved. In the next part, we talked about the different kind of errors that can be crop up. So we have to take care of those aspects so that in our proposed software that error should not be there. So now let's go ahead in the maintenance of the quality and the generation of the quality part by knowing the process of the software quality. So the first step in this regard is firstly define the requirement for the software control system. Means we get to know that these parameters must be defined in context of the proposed software should not reflect, or if it is some fault or failure are there, so that must be fixed. That after fixing, the things must be recovered. So the software quality, again, it's a cumulative sum of various factors which are involved and interdependent on one another. So that the process of software quality again starts by reviewing at the requirement of the software first, and then we get to know that okay, as per the given requirement, so the software should not show this kind of scenario or fault or failure at all. So again, entire process revolves around the review, in which we review the software development processes. Okay, if the things are there is some sort of fault and failure is there, as I use the proper software development process or methodology has been used, and why the our errors are coming up and how can we prevent it. So the entire process of the software quality, we take care of these aspects of the software, so that the things must be done in a very controlled way, because every time in the software industry, time is the most important resource, and we have to consider those aspects which remains under our control, so that the things remain under again control stages must be in our control. So it defines the process for measuring and analyzing the defect as well as the reliability and maintainability factor also, right? So by analyzing these processes in terms of that, okay, how many defects are there, how the reliability is breaking, at which level the reliability of the software is breaking, and how the things can be maintained. By getting the answer of all these questions, the process or the quality of the software can be enhanced. Software review can't be, now here comes a very important specific process that is called as a formal technical review. Formal technical review that cannot be defined as a filter for the software engineering process, because here involves the lots of aspects. So by just considering the requirement part, we can of the document that you are referring for the maintenance of the quality aspect of the software, either the correct parameter has been brought down or not. Consistency in terms of the modification and all, it must be ensured while under the formal technical review. Technical feasibility must also be ensured. Efficiency in terms of how computing the sourcing of the network or the computer and other IT resources is utilized under the implementation of this particular software. Apart from this, how our proposed software is fulfilling the standards of the company for which we are going to develop the software. So this compliance, this conformity of the standards, they all come under the with respect to the formal technical review. We have to, it means if the client hasn't shared this kind of documentation with me, so I can being the being the part of our software development team, I can ask for such a kind of document which reflect the policy or standards or compliance parameter of that organization. Under the formal technical review, there is two activities are performed. One is verification and another is the validation. Verification generally involves the review to evaluate whether the correct methodologies have been followed by checking the documents, plans, code, requirement and specification. This can be done with the checklist and walkthrough activity. So these are the small activities that help us to review the things, and verification is always considered as an important part because it ensures the second thought kind of activities which helps to fix the future problems as well. Validation, it typically involves the actual testing that takes place after the verification are completed. So it is in some of the book it is written as a V and V activities also. First V stands for the verification and second V stands for the validation. So validation reflects the entire behavior of our software, proposed software. So that is why it involves the actual testing and it always takes place after the verification is completed. Now, what is the objective of formal technical review? So, the idea behind this is to uncover the logic in the errors in the logic part, so that this can be ensured either we are in the right track or not. It also ensures that the software has been represented occurring with respect to the predefined standard of the organization. By knowing by means of formal technical review, the software under review meets the requirement or not. So just to cross check what the software is doing and what was there into this SRS part or LGD document. So this sort of formal technical review kind of activity is being performed. Apart from this, to make the project more manageable, because software development work is always work keeping in view of the time requirement, keeping in view of the cost part, and again the quality aspect also. So all in terms of project management approaches, the things must be under control, must be more manageable. So this is the idea behind the conduction of the formal technical review, so that things remains under controllable situation or scenario. And the schedule of the meeting and its agenda, because we are going to perform a formal technical review. So what all we are going to achieve under this formal technical review, that agenda must be clear for each and every member of the team who is a part of this formal technical review, directly or indirectly. So even the members who review the material and its distribution must be clear if it is required at the time of review or formal technical review. The reviewer must review the material in advance also. So the idea is to get a better glimpse of the things and all. Software concept and initiation phase. So in the initial phase, when the things are in the burning or clicking stage and all. So in this regard, the involvement of quality teams in both writing and reviewing the project management plan in order to assure that the process, procedure and standards which are identified in the development of the software are appropriate or not. They should be clear, specific and auditable also. So we, in the initial phase, being the project manager of the team, we have to ensure that every team member who is directly or indirectly involved into the software development work, they must have a clear idea, they must have a clear vision about the things that we are going to achieve. So apart from this question must be asked, has the design constraint been taken into account? Whether we have chosen the best alternative for this thing and all. So in the initiation phase of the in the quality part of the software, we have to have such a kind of mindset in the initial phase of the software. Now, software requirement. Now here comes the software requirement analysis phase. Now, SRS is ready with us. So we are into the analysis phase of that phase. So during the software requirement analysis requirement phase, we need to review and ensure the software requirement because the thing, if it is incomplete, so how the quality software can be developed. So we will ensure the completeness and the things are testable, and whatever way the things must be understandable as a part of each and every member, that must be expressible as a part of SRS. So we have to ensure, even in context of the performance parameter, interface context, so that must also be reflected in the SRS. So the output of the SRS analysis phase is that is in the form of these parameters which we are going to cover. That the output of the software requirement analysis phase is software requirement specification, right? So So because we are going to develop a software for a company, for a system, so that ensures these parameters, that is compatibility. So just to ensure the compatibility of the software, we have to ask this question: does the proposed software is whatever interface we have planned or we have designed? Does this interface enables the compatibility of the with respect to the external interfaces or not? Whether the specified models and algorithm that we are considering and numerical technique we are including it that are compatible with the core software, with the core system or not? Completeness. In this regard, all the requirements that was mentioned, either it was the implicit requirement or explicit requirement or latency requirement, that all was conforms to the functionality and performance system requirement constrained and all. So all the different kinds of users who are about to use your software, that user requirement must also be ensured. So we have to take a checklist in this regard to ensure the accuracy at this part basically in context of completeness. So that every user, either it is a super user, admin user, or operating user, or super admin user, and all different kind of user we have to ensure in that part. Consistency. Are the requirements consistent with each other? Is the SRS free of contradiction? Because sometimes certain contradiction arises at the legalities part and the part of customer expectations and all. So we have to ensure that the given requirement document must be consistent with each other. So whether the SRS uses standard terminology and definitions of the software, so all these things again must be documented so that once the people who are into the maintenance phase, they can manage the things in the near future of the software development lifecycle. Another important aspect is correctness. Are the requirements edited and correctly indicated in the proposed software requirement document? Is there a justification for the design or constraint? Sometimes the compliance parameters are there, so that must be ensured in terms of correctness parameter of the implementation. Traceability are the requirements which are traceable to the software because different stakeholders are involved. Your software documentation stuff, whenever you will find this word requirement, you always relate this word with that of the SR. Right? So in this context, how my SGD document should be. So again, if the entire designing phase will be completed in all aspects, then the functional part or the coding part will be complete. Now, so in this regard, SGD document must be complete. Whether in context of whether all the requirements have been addressed into the SGD document, it means I can derive an equation also in which we can say once the SRS is ready, then SGD will be ready, right? So again, my point to discuss over here is that if there is some sort of lattice, I have left 50 point over here. So it means there is not only a single chance to come that parameter which I have left into the SRS that will be here into this SGD form. It means if it is left here, so it can't be here also, right? So again, so the basic part what I am trying to convey is firstly by ensuring that now everything is there into the SRS. So again the SGD must be ensured that okay, whatever was there into the SRS part, it must be there into the SGD part, so that reflects the completeness as well. of the software design thing. So again, have the software requirement be properly reflected in the software architecture, because architecture, entire software architecture, again give us the entire layout of the thing, entire in terms of different modules or functionality which we are going to offer to the software. Again, our entire software design document must be consistent in terms of input and output format, in terms of other functionality that we have to reflect. Characters of the software must also be there. Design part must also be there with respect to the SRS and all. Completeness. Whether all the requirements have been met, this point I have already addressed in the first point. The software requirement being properly reflected into the software architecture. So, means whatever context, although we have covered all these aspects earlier also in context of SRS, but now we have to just ensure in context of SDD also. So again, consistency in terms of input-output format, interfaces design and all that must be mapped in one another. Does the SDD conform to the design documentation standard? Does the design conform only that which is specified into the SRS? It should not. There should not be any point to be left. There should not be any even extra point. And even if some extra points are there, so that must have a proper documentation evidence with that. Modifiability, again, every design is set to give, every design rather I must say that must be flexible enough to add on the more components to it. So that quality, if I have prepared such a design which is not so flexible, not so modifiable, so it means that will not be so flexible enough to use in the near future also. So while making the software design document, have a room of adding new components into that design document. So this is the important characteristic of each design if we leave a room for the modification for any aspect of the software. So the modules are organized such that the changes in the requirement only require changes to a small number of modules. Traceability. Again, here the traceability of the software design document will be done in context of the SRS. All the parameters that were there in the SRS that are also reflected into the LGD or not. Verifiability in context of again SRS, which reflects the well-defined notation has been. If I have used certain notation into the SRS part again maybe it is quite possible with that being a human being. Now this time I have used certain new terms. So again, the new terms must be the derivation of the previous terms. So if there is lots of gap in this part, so again it will create a challenge in the maintenance phase of the software. Now we are assuming that we have entered into the coding part. So again, once the coding is ready with us, so if you are again acting as a reviewer of the source code or you are auditing the entire source code part, so what aspect you have to capture? That is, although we have to think in this way, although all the code is there in terms of all aspects of the module, in terms of coding is there, consistency must be there, correctness means all those aspects must be matched with the code which is readily available with us at the time of development, once the development is over. So now again the things will enter into the installation phase. Again, a new set of challenges will arise in this phase. So while reviewing the source code, what all challenges we are going to face, that will come up, and that again will be documented also. Software reliability, that again is a very important metric that typically measures as per the unit of time where the probability of failure generally is the time dependent. These two measures can be easily related if you know the frequency with which the input are executed per unit of time. And mean time to failure is the average interval of time between the failure. Rather, I must say that mean time to failure is sometimes referred to as a unplanned failure also, right? And mean time between failure is called as a planned kind of failure. Right? I can assume that there could be a little bit kind of predictability is also there. And being time before failure reflects the kind of schedule. We can schedule this kind of thing whenever the before the failure of anything, we can plan this kind of thing. So software reliability, as per the IEEE standard, the probability of that software will not cause the failure of the software for a specified time under specified condition. Rather, the probability is a function of the inputs to and the use of the system in the software. So, based on to the input which is given to the software, how the software reflects in terms of the acceptance or digestion or the implementation of that input, that reflects the quality of the software, and which is collectively called as the reliability of the software. So the input of the system determines whether the existing faults, if any, are encountered into the software. If they are encountered, they will be again communicated to the right channel so that the things can be bugged or it can be bug free. So the ability of the program to perform its required functions accurately and reproducibly under the stated condition for a period of time is called as a software reliability. There are different models for this thing. Another model which has been developed to determine whether the software defect or failure has occurred. All these models describe the occurrence of the defect failure as a function of time. So these allow us to define the reliability in context of the security also. So these models are based on certain assumptions which we are going to cover. That is, the failure are the independent of each other. Is that one failure has an impact on another? It is quite possible into the software industry that if one thing will happen, definitely it will impact the other part also. So because the things are intermingled with one another. So the inputs are, by considering the reliability model, we have to assume the random sample, and sometimes we again here we apply the Pareto principle also. Don't take the things in the sequence. Don't follow a assumed fact, or not assume, rather I will say that not assume, go for the set pattern all the time, go for some random sample also. Failure intervals are independent and all software failures are observed. Time between failures is exponentially distributed across different software. Again, it depends upon type of software also. Although again, for the software quality is a very cumulative quality, which is which is the sum of various parameters. Here in this slide, I have the data I have captured from your blog. So you just remember at least 2 3 ISO standard with respect to the series, that every series or series of standard have its own set of quality parameter which is defined or which are associated with that series. So if I'm talking about ISO, IEC 9003 and all, so these quality standard, they focus on software engineering guidance for the application of ISO 9001 to 2000. Means while every software has its own set of beautiful or specification parameters. So depending upon the need of the project or depending upon the need of your software, what the client is looking for, we have to provide quality standard. So if it is possible for you to remember 2 3 standards, so that if that kind of question will be raised, so you can mention that these are the different software quality standards, and every software quality standard has its own set of specification in them. So with this, we are finished with the block 1 part. Now we are entering into the block 2, which is the software project planning. Entire project software, software development work, it revolves around the different project planning and project management practices. So we are going to cover all this now. Software pattern is what basically, in the very beginning we talked about the Q square formula, in which first Q stands for the quantitative approach and another Q stands for the qualitative aspect of the software. So today we are going to cover that Q parameter again, which is called as the matrix, because it is assumed into the software industry that anything which is measurable, that is improvable also. So a software matrix is what basically, it is quantitative measure of the degree to which the software system or process possesses some property. So metrics basically they deal with the measurement of the software processes and the software product. So metrics, every metric quantifies the characteristics of the process or a product. And metrics are often used to estimate the project cost and project schedule, which is the core part of project management approach. So if we talk about the software development life cycle, so in this regard, in every phase of the software development, we are having some sort of that some sort of what we call it as a matrix. When we are into the initial phase of discussion with the client, we have get to know about what is the scope statement of that of the client, what the client is expecting, what we are about to deliver. So again, this is the kind of also matrix, what exact parameter they are looking for. How much time this software project will take, how much effort will be involved, how which skill set is required, but again, in the designing phase, all the design documents that you are presenting, the DFE, diagram, flowchart, use case. Again, it's the kind of matrix of the software. Every, if I am in the testing phase, how many bugs have been found out, fault, how many files are, faults are there, and errors are there, and what are the customer expectations, how much is the traffic of my website, how the people are responding, everything, every aspect of the software is considered as a software matrix. So all these aspects we have to consider under the software matrix. So what is the goal of this matrix? So the idea is one and only one. That is why to get touching all these matrix of quantitative value so that we can prepare the qualitative software. So the idea is to improve the quality of the software by knowing the quantitative measure parameter of the software. So development team productivity is concerned with the product. Even if let's say three people were involved in the development of the software, now that software is getting very it is going high or it is coming best to the industry lot. So again that people who are indulged into that, the development of that software. Again, that the productivity of that people and what kind of practices, methodology they have used, all these again is a kind of matrix. So we just want to create another success story the way you have created earlier also. Again, this is the only way to capture the whole, to capture the idea of matrix basically, so that the repeat success story can be created or repeat success formula can be applied. So measure the software development output as a function of effort and time. So again we can measure the usability of the software by knowing the certain parameters. If you have created a software which is the interface is so user friendly, people are using it very enthusiastically. They are finding it very user friendly, very helpful. This kind of way. So if the things are going well, so we can reuse it again and again. So now there comes because being a human being without any need we don't do anything. So what is the need for the project manager? To indicate the quality of the product to assess the if we really want to know the quality of the software product, so again we need to have certain metrics in our hand. So that we can assess the productivity of the people who are involved, we can even find out the kind of effort they have applied. So or in our example, our producing the software product. So to assess the benefit derived from the new software engineering methods and tools, to form a baseline for the estimation. Once we are having the matrix with us, we can get an estimation, okay, how the things will be move on, or what would be the possible, estimation or budget for this particular software or project. So even if we are having the project matrix with us, it will be we will be able to have or justify some sort of new tools or let's say some additional training is to be conducted for the smooth functioning of the team or for the better outcome of the work and all. So once we know we have each and everything with us, so we can manage the thing also. Again, there are two key are mentioned. Also, there are four key principles which may we have talked earlier also. First P stands for project, another P stands for product, and next P stands for process, and the last stands for people. Project, product, process, people. But in your book, whatever is there, we are going to discuss. That is two dimensions are there. That is product and process. When we talk about project part again, because the entire software development is taking consuming factors with the help of project management approach. So we are in the initial phase we have to define the start date, we have to define the end date along with the phases of the things which will be carried out between the start and the end. So that matrix again we call as a people matrix. And product matrix that we are going to cover. So product matrix of the software product at any stage of its development from the requirement to the installed software. So the moment our journey of software development starts, from that moment the product matrix are generating basically. So that product matrix may measure the complexity of the software design. It may measure the size in terms of lines of code or the function points of the final program and the number of pages of the documentation because we really want that our software should be used by the entire team member at different level of user also. So just for the proper implementation or proper usage of my software, I need to prepare certain documentation also. Again, yes, again it's an extra effort also because I need to maintain the macros and graphics just to make my macros more attractive. I have added not new rather I have added some related or relevant graphics also. Again, it's a very important activity. Again, it's a cost to the organization. So how many time or how many days have been has been there in the preparation of the particular manual document or training document. Again, that relates to the matrix of that particular software product also. So yes, we talked about this. Yes, lines of code is again a matrix, which is possibly the most extensively used matrix in terms of the size of the program. And the reason is that the line of code can be specified. Even a non-technical kind of person can get to know that okay, how many matrix, how many efforts could be possibly involved into it. So line of code may be include executable source code and non-executable program code like the comments and all. That we talked earlier also because comments are always included to enhance the reliability of the software to add additional information to the software. So yes, there is a scenario that again I have captured from your stuff in which the different modules we are going to develop and every different module is considering the different amount of effort. Let's say we are assuming that in the development of the module one, that three people were involved and we will develop the 24,000 lines of code and all. So by keeping this parameter, looking at this data, we can put this value into this value and so that productivity. मैं क्लास में हूँ आपको कॉल बैक करती हूँ क्लास में हूँ So line of code by knowing the lines of code we will be able to get an idea that how many the productivity of that person involved into the work. So by knowing this values and how many people were involved or how many months, this way we can find out the again the kind of matrix. Again, because sometimes in the initial discussion, when the things are going on, immediately we can't judge the amount of effort or budget or that the amount of cost that we should ask for this particular software from the client. So by knowing that past project matrix in this way that we have captured from the past project, we can put the simple way of idea into this parameter and we can get an idea that okay this the current project which is in hand for which we are going to discuss that what could be the possible estimation for this particular project. So advantages of size-oriented matrix is that the lines can of code can be easily counted. I just problem this thing that this even layman who don't know anything about the technical aspect of the software, he can just jot down the lines of code and he will get an idea that how many code has lines of code has been developed. But yes, it is also a debatable part among the software developer because by just typing a line will not ensure that how much effort has been sometimes applied at the back end of the thing. So yes, the disadvantages of size-oriented matrix again it is important part of the examination point of view that discuss few disadvantages of size-oriented matrix also. So yes, these are language lines of code are language dependent basically. Like we do into the Python, we single line of code for the starting of the thing, while in C and C++, we have to write 4 to 5 lines of code for the starting of the, swapping of the numbers and all. So, because the things are again, language defined, someone is trying to enter. So that is this is the biggest disadvantage in this context. So another important thing is their use in the situation requires a lot of detail which can be difficult to achieve sometimes. So by knowing the disadvantages, we have to take again we have to come the project related at each aspect of the software development. So if you think that the proposed software is having so much sensitivity, so much complexity is involved into it. So again, line of code should not be used then because certain estimation can't be derived. Or if it is to be used, taken care, or if it is to be considered, then we then each and every detail of the software will be taken. Function point metrics reflects the kind of functionality our software is offering, the kind of modularity or the kind of features our software is accepting. That count is called as a function point. So function point metric instead of lines of code, it means the functionality of the program used or the functionality which is derived delivered by the software, and it is measured by using the software called as a function point. So if I know my software is having a registration module, my software is having a login module, my software is having a display report option. So in this